So, hello students, how are you? Good morning to all. I hope you are doing great. So, here we are with our question discussion for laws of motion, part 2 for friction. Okay. So, firstly, we will make sure the voice is audible to you and the screen is visible to you. Just let me confirm. So, JNV Bhavnagar we have. So, please confirm the screen is visible to you and I'm audible to you. Just write this thing in the chat box. Okay. So that we can start the lecture. We will wait for 2 to 3 minutes. Okay. Then we will see. Okay, thank you. So we will wait for 1 more minute. Na? Let the others to be join. Then we will start the lecture. Okay. So you have any kind of doubt in the previous session? Have you got everything? Friction is clear to you? JNV Bhavnagar. Friction is clear to you? Question solve हो रहे हैं? Write this thing in the chat box now. Okay, good. So today is Sunday, na? So I think most of the student enjoying the Sunday. Okay, we will wait more 30 more seconds. Okay? Then we will start. One more student we have. Who is this? It's Kruti Hanhat. How are you? Good morning. Okay, then we will start the lecture. जुड़ते रहेंगे साथ में. No problem. Okay. So here we are with our lecture number uh, 2 on friction, and this is the question discussion on friction. Okay. Now the very first question is on your screen. So here a block of mass 5 kg is placed on a rough surface in which mu s and mu k both are same. Mu s and mu k, what is that? It is the coefficient of friction. Okay, static friction and kinetic friction, and it is zero point 0.6. Both are same. Two forces acting on it as shown. So the first, find out the range of force F such that the system is in equilibrium. So here the force we have, the unknown force is F. Okay, so you have to find out the range, means F minimum and F maximum. So that is the thing you have to find out. Okay, so I'm giving you 2 minutes to solve this question. So use your knowledge that we have learned in the previous lecture for friction and try to solve it. Huh? I'm giving you two minutes to solve this question. Okay. ये तो शालिनी गोहिल भी है. Good morning, Shalini. How are you? Good morning. Try to solve this question. We have to find the range of at the external force F, minimum and maximum. Okay. So are you doing it? JNV Bhavnagar, Shruti Hanat, Shalini Gohil. Are you solving this question? Then I will start solve. Just write this thing in the chat box now if you are solving it. Solution. So what we are going to do firstly, we have to find out the range of this force F. Okay. So that it will not move. The system will not move or remains in equilibrium. Okay. So firstly, we will try to find out the forces on it. This is the normal reaction and this is the weight, means mg. Okay. Now, if firstly I will take in first case, in first case, we find out F minimum. So firstly, we will do the F minimum. Okay. Look, when this force is minimum, so this force is the leading one. So block will try to move in this direction. Okay. So we have a friction in this direction. This is the frictional force we have, small f. Okay. If I write the uh, equation for equilibrium, for equilibrium, equilibrium के लिए क्या? All the forces are equal and opposite. ठीक है? Sum of या net force is equals to zero. Means the force on LHS is equals to force on RHS. So here we have 100 Newton equals to, this is the only force in the LHS. On the right hand side, we have minimum. We have this F minimum and this F. If this force is minimum, so this must be equals to maximum. That is why this block going to hold na, because this 100 Newton force is capable enough to pull this. So we have to apply, if this force having its minimum value, so this friction must to be attained the maximum value. Okay, that is how this block is remain in equilibrium. Okay, so 100 is equals to F minimum plus what is the maximum value of this force? It is limiting, which is mu times n. Okay, so 100 equals to F minimum plus mu times what is the value of n? N is equals to mg in this case. N here equals to mg. So put this mg here. Okay. Now put the values. We have provided the mass which is 5 kg. So F minimum plus we are provided with the value of mu which is 0.6. 0.6 multiply mass which is 5 and g is 10. So F minimum we have 100 minus 30 which is 70 Newton. This is the minimum value of this force. Got it? Easy है ना? The very simple concept is here कि if this force is minimum, then this force should be maximum. Okay, got it? So in the next situation, we are going to see what is the value for F maximum. Okay, यहाँ तक नोट कर लो आप. नोट कर लिया. Okay, so in the second case, we have to find out the value of F max. Okay, now the situation here is this is the block. Okay, and this force F here is maximum then. Now, if it is maximum, okay, so friction will try to oppose it because it tries to pull the object in this direction. So friction will act in opposite direction. This is F here. And another force 100 Newton is also acting. Okay. So what should be the equation for that? It is F maximum equals to 100 plus friction. And what should be this friction? Is it maximum or minimum? It will be maximum because this force applied is maximum. So friction will apply its full potential to stop it because this system has to be remain in equilibrium. Okay. So this is F maximum. Okay. So F max equals to 100 plus mu times n is 100 plus. What is the value of this mu n? It is 0.6 mg 5 into 10, which is 130. So this should be the value of maximum, 130 Newton. So the range of this force will be from 30 to F less than equals to 130. Okay. So this is the answer to this question. Okay. I hope you got this. If you have any kind of doubt, you can ask in the chat box right now. Okay. So this force could have a minimum value of 30 Newton and the maximum value is 130. Okay. Now move on to the next question. Yeah. This is a very conceptual question. Huh? So please pay attention to this question. Okay. Solution. Now the question is, consider an inclined plane whose upper half is rough and lower half is smooth. The friction coefficient of the surface is mu. A heavy rope is placed on the inclined plane such that it remains in equilibrium. So what minimum fraction of rope is required on the rough surface for equilibrium? Okay. So here we are. We have this rope. This is our inclined plane. Okay. And this is our rope. The upper half, like from here to here, it has friction mu, and this is mu is equals to 0, means it is smooth from the half side of it. Got it? So this is the rope we have, and it is heavy rope having some kind of mass, you know? So I would consider the total mass of the rope here. Total mass of rope equals to m. Okay, and let's say Uh, just a second. Yeah. Let's say some of the portion, not exactly half, some of the portion of the rope is in upside, and let's say it is x. So here it L minus x. If the total length of the rope is L, so it is L minus x is downside and x is in the upper side. Upper side is rough. So on the rough side, we have x amount of length. Okay. And in the smooth side, we have L minus x amount of length. Similar uh, analogy goes for the mass also. And some of the mass is on the rough side, some of the mass on the smooth side. So let me try to draw it. Let's say this is our rope. Okay. And from here to here, it is on the rough side. And let's say this mass is K. The value of mass over on the rough surface is K. So this would be M minus K here. Got it? Okay. Now try to draw the FBD of these two. We can consider it two block system. Na? This block has M minus K mass and this block has K mass. Okay. So we will try to find out the FBD of this rock. Now this angle is theta here. Okay. Now if I split this rock from this point, what will happen? What will happen? This system is smooth, so this trying to go downside, lekin it remains in equilibrium. We have to find that condition. Okay, it remains in equilibrium. So this part of the rope try to pull the upper part in the downside. Similar way में this upper part trying to pull the rope in upper side. Okay, equal and opposite. So this will have a tension T here. Okay, got it? Now a mass mg, mass of this rope will also acting downward, which is m minus k times g. Okay, and there is a normal reaction, which is n1, let's say n1, because normal reaction is different. Why it is different? Because mass is different. Okay, here we have m minus k and here we have k. Okay, got it? So if this angle is theta, this angle is also theta. So here we have m minus k times g cos theta, and in this side we have m minus k times g sine theta. Got it? This is for the lower half, which is on the smooth side. Smooth side. Okay. Now on the rough side, yeah. For the rough side, we have this rope here. Okay. It has a mass of k. So the mass kg, it is not that kg. K is representing mass. Okay. And there is a normal reaction N2. N2 here. Because mass is different, so normal reaction will also be different. Now this part of the rope trying to go down because of this mg. If this is theta, so this will be kg cos theta, and this is kg sin theta. Kg sin theta. Okay, look, this rough side part had apply a tension on the lower side part in this side. So it will experience a tension in the opposite side, equal and opposite force. Okay, you can also draw it here. This is the reaction by this block and this is the reaction by this block. ठीक है? So we have a downward tension also. Okay. So because of this kg sin theta and tension T, this will try to go down. Okay. So that is why we have a value of friction in the upper side, because here friction is present to stop this. Okay. Now try to balance these forces for equilibrium, and we will do it on the next page. So for smooth side, we have this, in which m minus k g sin theta. This is normal reaction. This is m minus k cos theta, g cos theta. This is the only force we have, and in this side we have tension. So equilibrium, for equilibrium, all the forces must be equal. So we have T is equals to m minus k times g sin theta. Okay. This is equation number 1. For rough side, we have this diagram. We have a tension here. We have kg sin theta here. Okay. We have a normal reaction, and this is the kg cos theta. And there is another force, which is friction. So we can say that friction here is tension plus kg sin theta. Okay. Now, if you put the value of friction over here, this is friction, which is equals to T plus kg sine of theta. Got it? Now, put the value of tension from equation 1 in this equation. So you have F is equals to m minus k times g sine theta plus kg sine theta. So friction we have as, if we multiply g sine theta inside, so it is mg sine theta minus kg sine theta plus kg sine theta. This kg sine theta and sine theta will cancel out. So we have F is equals to mg sine theta. So you can conclude that whatever the portion is on the smooth surface, but this friction is holding the entire mass of the rope, because if this is the inclined surface and there is no friction, so we have a total mass mg. This is the mg cos theta, then here is mg sine theta. So this friction force is holding this complete mass. Okay. So it is not like that कि रफ सरफेस पे थोड़ा मास है, सो वो उसी को ही सपोर्ट करेगा. नहीं, फ्रिक्शन इज सपोर्टिंग द होल मास. Got it? So that is the thing I want to tell you. I hope you are clear with this. JNV Bhavnagar, you are the only one here. So you got this. Write in the chat box now if you got this. Okay. So this is the value of frictional force that we have in this block. Got it? Hello, Jaydeep. How are you? So I hope you are clear with this question. Okay. Move on to the next question. Yeah. This is a very conceptual question. Okay. So JNV Bhavnagar, are you there? Please write in the chat box now if you are there. Okay. so that I will give you some time to solve this question. Otherwise, I will start solving it. Okay. Okay, Jaydeep. So this angle here is theta. This is the block of mass m. This is the block. This is the wedge of mass 2m. Okay. So a wedge of mass 2m and a cube of mass m are shown in figure. So between cube and wedge, there is no friction. The minimum coefficient of friction between wedge and ground so that wedge does not. This is the ground we have. Okay. And there is no friction between this block and this wedge. So mu is 0. But here we have some kind of friction. Let's say mu. Okay. So a wedge of mass 2m and a cube of mass m are shown in figure. Yeah, we have seen the figure. Between the cube and wedge, there is no friction. The minimum coefficient of friction between wedge and ground so that wedge does not move. Okay. So in these types of question, we have to draw two coordinate axes. Okay. Like one for this block M and one for this wedge 2M, because the wedge does not move. We have to find the condition when wedge does not move. So we have to see the forces on wedge. Okay. Got it? So for block of mass M, if we try to draw the FBD of this is block M. It has a downward force mg. This angle is theta, mg cos theta. Here we have mg sin theta. And since there is no friction in this object, okay, we have this also. This is the normal reaction. And there is no friction, it is free to slide down. Okay. From here we can say that n is equals to mg cos theta. Got it? So now for block, for wedge 2m. Okay. We try to draw the FBD. This is our wedge. Okay. Now the weight of the wedge is acting downward, which is 2 mg. Got it? There is a normal reaction provided by this block, mass m, which is acting in downward direction, equal and opposite. It is applying in the upward direction for mass m. So for wedge, it is acting in downward direction. There is another reaction also, which is provided by the ground. You can say N1. The ground will provide a reaction. Na? You have to find out how many surfaces are in contact. So first is this block and second one is this ground. So we have two normal reaction. Okay. Now, any other force? No. So we have to find the condition so that this wedge does not move. Okay. You will see if you try to resolve this, this is n. If you try to resolve this in this direction, because this wedge can move in this direction or in this direction. Okay. So we have to resolve the forces in the direction of movement so that it will be easy for us. Okay. So this angle is theta. Okay. And if this angle is also theta, let's say it is theta, na? Just a second. This angle is theta. So we have this angle as 90 minus theta. This angle is 90 minus theta. So here we have n cos theta, but here the theta is 90 minus theta. So cos 90 minus theta will become sin theta. Okay. And there is a downward force we have, which is the component of this n, which is exactly equals to n cos theta. Why? Although it comes like n sin theta, but theta we have here is 90 minus theta. So sin 90 minus theta will become cos theta. So how many total forces we have? The upward forces, vertical forces will balance each other. We have N1 in the upper side, and this is the only force we have in the upper side. Other force we have 2mg in downward plus N cos theta. This is equation number 1. Okay. But you will see there is only unbalanced force N sin theta is here, which is trying to pull the block in this direction. Okay. In this direction. So friction must act in the opposite direction to it. This is the value of friction. So friction will act here in the opposite direction. Okay. So for that, this friction force, this frictional force greater than equals to this n sine theta. Okay. And this friction is nothing but mu n. Okay. Now, what should be the n? N here is n1 because we are seeing this for this wedge. So normal reaction of the wedge will encounter. Got it? So mu n is greater than n sine theta. Okay. So if you will see, this is always greater than, this term is always greater than this term. So it has a minimum value when it is equal. Okay. Otherwise, it is always greater. So we have to find out the minimum value of coefficient of friction. So we have to equate this term. Okay. So this mu n1 is equals to n sine theta. N sine theta. What is this value of n1? N1 is n. N1 here is 2mg plus n cos theta. N cos theta plus 2mg equals to n sine theta. Okay. So mu here is nothing but n sine theta divided by n cos theta plus 2mg. Okay. What is the value of n? N is for the wedge, which is equals to mg cos theta. Okay. So put this here. It is mg cos theta sin theta divided by mg cos square theta plus 2mg. Okay. Let me check with the value. What is the value of theta given in the question? Okay. So just a second. It is 45. Okay. So theta we have as, put theta is equals to 45 degree. Okay. So mu minimum we have mg cos 45 1 by root 2, sin 45 1 by root 2, 1 by root 2 into 1 by root 2. Let's say one more line, 1 by root 2 mg 1 by root 2 का square plus 2 times mg. Here we have mg by 2 divided by mg by 2 plus 2 mg. You can take out mg as common. So it is 1 by 2. It is 2 to the 4 plus 1, 5 by 2. So it is 1 by 5. You have 0.2. So mu here is minimum value of mu is 0.2. This is the coefficient of friction. Let me tell you what we have did. Firstly, we will equate this vertical force, this M block M. Then we have seen ki what is the unbalanced force which can cause the motion on this wedge. So we have seen this N sine theta is that force. So we have equate this force with friction. So friction should also be greater than this N sine theta, this unbalanced force, so that this wedge does not move. So the minimum value we equate it, and then we put the values all over it, and then we calculate the minimum value of this coefficient of friction. Okay. I hope you got this. If you have any kind of doubt, you can ask. Okay. Now try to solve this question. This has been asked in 2020. Okay. Try to solve this. A block start moving up an inclined plane of inclination 30 degree. Okay. With an initial velocity of v naught. It comes back to its initial position with velocity v naught by 2. The value of coefficient of kinetic friction between the block and the inclined plane is close to I by 1000. Now the nearest integer I you have to find out. Okay. So this is the inclined plane. Let's say this is the inclined plane on which this block is present, and it is moving up with velocity v naught. But when it comes down, it has a velocity v naught by 2. Okay. So try to solve this question. Now we have to find out the value of this I. Okay. This angle of inclination is 30 degree. That is it. Okay. So let me solve this question for you. The first case we have taken when block is moving up. Okay. So when block is moving up, we have to. So this is the FBD for that. Initial velocity v naught. Okay. And if you try to draw the forces, this is mg. This angle is theta. Let's say firstly it is theta. We will put the value in the after. Okay. Mg cos theta. This is mg sin theta. Okay. Now initially it is going up, so friction will act in try to opposite. So it will act in downward direction. This is friction. So the acceleration of the block, you will see it is mg cos theta, mg sin theta plus, because friction is also acting in the downward direction. It is friction equals to mass of the block into acceleration 1. Okay, in the first motion when it is going up. So acceleration I have considered a1. So a1 here is g sin theta plus f. Now put the value of f. F is equals to, let's say f is equals to mu n, which is mu mg cos theta. So we put the value here. Mu g cos theta, because m and m got cancel out. So it is g sin theta. Sin theta has value 30. So sine 30 is 1 by 2 plus mu g cos 30 is root 3 by 2. This is equation number 1. This is acceleration 1. Okay, got it? Now, from this equation, we can apply v square minus u square is equals to 2as. Okay. Initial velocity we have v naught, and the final velocity we will be 0, because when the block reaches the topmost position, it stop. Then it start moving because it is changing in direction for velocity. So that is why the velocity at the final position, at the top position, will be 0. Acceleration is also in negative direction. So we will rectify this negative. So this is simply v naught square is equals to 2 times of a1 into s. Okay. S is the length of this wedge. So this is also the equation number 1 you have. Equation number 2. Okay. From here, or you can say the general value, you will write S here is equals to V naught square by 2A1. This is equation number 1. Okay. Now, the second scenario, when block is moving down, downward. So when block is moving downward, all the forces are same, but only the friction will change its value. So if the block is moving downward and at the initial position where it started, it has a velocity v naught by 2. Okay. So this is a force mg sine theta, always there, mg cos theta. And if this block is moving downward, so friction will act upward. So this is the value of friction. Normal reaction n is there. So if I try to draw, if I try to write the equation for it, it is mg sine theta minus f, because it is opposite in the direction of motion, equals to mass of the block into acceleration. Why I mentioned this a2? Because it is moving with a different velocity now. Okay. So mg sine theta minus, put the value, mu mg cos theta equals to mass into acceleration. Cancel this m from both the side. So a2 you have as g sine theta minus mu g cos theta. Put the value of theta. Theta is 30. Theta is equals to 30. So it is g by 2 minus root 3 mg by 2. This is equation number 3 we have. Again, we will apply this v square minus u square is equals to 2as. The initial velocity for this, because it is moving from the upside. So at the topmost position, it has initial velocity 0. And in the downside, it has a velocity v naught by 2 as given in the question. So this is 0. So you have 2a2s is equals to v naught by 2 ka whole square. So from here you can say s is equals to v naught square by 2 to the 4 times 8a2. Okay. If you compare these equation, this equation number 4 with this equation number 1, what do you get? You have a1 square by, sorry, v naught square by 2a1 is equals to v naught square by 8a2. 2 4 ja 8, and this will cancel out. So you have a1 is equals to 4 times of a2. This is equation number 5. Okay, you will see. This is the equation. Fourth, we have s is equals to v naught square by 8a2. This is equation number second we have. First, second, third, fourth. So equation number 2, we have v naught square by 2a1 and s and s are equal. So we have compared this. Okay. Now put the value of a1 from equation number 1 and a2 from equation number 3. So from equation number 1 it is g by 2 plus root 3 by 2 mu g equals to 4 times g by 2 minus root 3 by 2 times mu g. यही है ना? Let's check. A1 is g by 2 plus mu g root 3 by 2 and A2 is g by 2 minus root 3 by 2 mg. Okay, not m. M is not there, only g. Okay, and mu, it is mu g. Okay, now g you can cancel out, so it is 1 by 2 plus root 3 by 2 mu is equals to 2. I have multiplied this 4 inside, so it will become 2 minus 2 root 3 mu g, mu only, not g. So here you have to calculate this. If I take this mu this side, so it is root 3 by 2 times plus 2 root 3 mu equals to 2 minus half. So take the LCM, it is 2 times 2 root 3, so 4 root 3 plus root 3, 5 root 3 divided by 2 equals to 2 2 ja 4 minus 1, 3 by 2 into mu. So this 2 and 2 will cancel out. So you have a value of mu is equals to 3 upon 5 root 3. This 3 you can write root 3 into root 3. Root 3 will cancel out. So you have mu is equals to root 3 by 5. Okay. Root 3 has a value of 1.732 divided by 5. If you divide this, what you will have? If you multiply with 1000, and here you will also multiply with 1000. So you have 1732 overside divided by 5 times into 1000. Okay. Divide this 1732, 5 3 ja 15, 2 3 5 4 ja 20, 3 2 5 6 ja 30. 0.4 20. Got it? So you are getting 346.4 divided by 1000, the mu value. Okay. Now, in the question you will see, we have to calculate this I by 1000, and this is the value of kinetic friction. And we are getting the same 346.4 V divided by 1000. So in the denominator, we have the same value 1000, but in the upper side, it is in the fraction. Now, read the question carefully. It is asking the nearest integer to I. So nearest integer to this number is 346 divided by 1000. So the value of I here is 346. Got this? I hope you are got this. Okay. Yeah, you can try to solve this question. And before this question, I want you to solve this type of question. Okay. Now try to solve this question. There is a tendency of this question to be asked in your examination. This is P force and this is angle theta. Okay. A block is placed on a rough surface. Find out the minimum force P required to slide the block. This surface is rough, so it has some mu. Okay. Now we try to solve this. So you can see, you can resolve this P cos theta. This is P sin theta. Another force is normal reaction to this block. And this is weight mg. Okay. Now, this P cos theta is the only unbalanced force here. Okay? So the friction will act in this direction, opposite to that. It always opposes the relative motion. So this is the value of friction you have. Got it? So the minimum value of force to require to slide this block. Okay. So we can say this P cos theta should be greater than or equals to this friction for the movement of block for motion. तभी तो मोशन होगा ना. When this P cos theta is greater than this friction. Now you can see it is always greater than. Always. This is greater than or equal. So the minimum value it can take is just equivalent to F. So minimum value, for minimum value, for minimum value, this P cos theta equals to this F. Okay. And this F should be the limiting one. ठीक है. क्योंकि अगर P cos theta का मिनिमम ही लिमिटिंग फ्रिक्शन के इक्विवेलेंट है, then जरा slightly increasing the value of P cos theta will slide the block. Okay. So here the vertical forces that we have, sigma Fy is equals to 0 होना चाहिए, because there is no motion in vertical direction. So vertical direction में we have P sin theta plus N is equals to mg. So from here N is equals to mg minus P sin theta. Now this is equation 1. What is the value of friction? Friction is mu times N. So friction is mu. What is the value of N? N is mg minus P sin theta. Mg minus P sin theta. So F here is mu times mg minus mu P sin theta. Put this value, put this in equation 1. So when we put this value in equation 1, it is P cos theta equals to F, and F is mu mg minus mu P sin theta. Got it? Now take this mu P sin theta on LHS. So we have P as common. So we will have this value cos theta minus mu sin theta equals to mu times mg. This is equation number 2b. Now we have to find out the minimum value of this. This is P is equals to mu mg cos theta by cos theta minus mu sin theta. Now for P tends to be minimum, so this denominator should goes to be the maximum value. For P to be minimum, this denominator is deciding what should be the value for P. Okay. So for minimum value of P, this denominator should be maximum. So we have to find out this maximum. Cos theta minus mu sin theta का maximum. Here theta is the only variable. So we would differentiate this term with respect to theta and put this equals to 0 for the maximum value. Okay. For maximum. Got it? So d cos theta. What is the differentiation for cos theta? It is minus sin theta. Minus mu times, mu is constant, sin theta का differentiation is cos theta. Okay, is equals to 0. Got it? Now, from here you can say this sin theta is equals to mu cos of theta. Okay. Just look at the question. If any kind of mistake that we have made, this P cos theta, P sin theta, this is N, this is mg. So this N plus P sin theta would be equals to mg. And here is mg minus P sin theta. Okay. If P cos theta must be equals to this friction. So it is mu N, mg sin theta cos theta. Okay. Yeah. The one mistake that I have made, but you guys had not paying attention. So that is why you do not encounter this. Okay. And that is why I have made this mistake. जानबूझकर. Okay. When I take this mu p sin theta in LHS, so it will become plus now. So this term will become plus. This term will also become plus. This will also become plus. So that is why sin theta is equals to mu cos theta. So we have tan theta is equals to mu. Okay. From here you can say sin theta would be, if this is mu by 1, this is perpendicular, this is base. So hypotenuse will be square root of the square of perpendicular and square of base. So it is perpendicular over hypotenuse, which is mu square plus 1. Same goes for, so sin theta we have mu over square root of mu square plus. Cos theta we have 1 upon square root of mu square plus 1. Now, what do we have as P? P is nothing but mu mg divided by cos theta plus mu sin theta. Let me just confirm it. Okay. Cos theta plus mu sin theta. Put the value of cos theta and sin theta. So it is mu mg divided by cos theta is 1 upon square root of mu square plus 1 plus sin mu times mu over square root of mu square plus 1. Okay. This mu and mu will become mu square. So in the lower side, we have square root of mu square minus 1. Sorry, plus 1. So it is mu mg divided by 1 plus mu square divided by square root of 1 plus mu square. You can also write this as like this. 1 plus mu square, 1 got cancel out. So we will have a value of mu mg divided by square root of 1 plus mu square. This is the value of force P, minimum force P, that is required to slide the block. Okay. So this is it from my side. Okay.